Hello, we are Team O, John Eris Dahayan, John Timothy Gallardo, Gabriel Nicolay Garcia, and we are discussing about IC fabrication of passive devices.
Electronic components were in passive devices such as resistors, capacitors, inductors, microstrip lines, impedance matching components are integrated in one whole package. Early forms include resistor, capacitor, RC networks, and RLC networks. Early forms during 1960 are when 4 to 8 resistors packaged in form of single inline package by Vishay Intertechnology. Other types of packages are DIL and DIPS were used. They are still used even though monolithic integration has progressed. Today, portable electronic devices include discrete passive devices in circuit or module. During the 1960s, epitaxial deposition was developed. Epitaxy refers to a type of crystal growth or material deposition in which new crystalline layers are formed with one or more well-defined orientations with respect to the crystalline substrate. The deposited crystalline film is called an epitaxial film or epitaxial layer. Bell Labs developed the technique of epitaxial deposition. A single crystal layer of material is deposited on a crystalline substrate. Epitaxial deposition is widely used in bipolar and submicron CMOS fabrication. Also, Kang at Bell Lab fabricates the first MOSFET. During the 1961, Fairchild and Texas Instruments both introduced commercial ICs. For 1962, transistor logic invented in semiconductor industry surpasses $1 billion in sales. For 1963, the first MOS IC was fabricated. Passive devices can be packaged, bare dies, or stocked in 3D with active ICs in an assembly. A bare die or a bare chip is an integrated circuit that has been cut out from the wafer and is ready for packaging. Standard types of package are SIL, SIP, TSOP, QFP, PLCC, and LCC are used in electronic packaging. An SIL or single inline packaging is an IC package that has a single row of LEDs protruding from the bottom of its body. It is not as widely used as a dual inline packages such as the PDIP and the SIR-DIP because of its limited number of pins. SIPs are often used in packaging networks of multiple resistors.
Another type of packaging is the DIP or dual inline packaging. In microelectronics, a dual inline package is an electronic device package with a rectangular housing and two parallel rows of electrical connecting pins. The package may be through-hole mounted to a printed circuit board or inserted in a socket. The next type of packaging is the TSOP or Thin Small Outline Package. It is a type of surface mount IC package. They are very low profile, about 1 mm, and have tight lid spacing as low as 0.5 mm. They are frequently used for RAM or flash memory ICs due to their high pin count and small volume. In some applications, they are being supplanted by ball grid array packages which can achieve even higher densities. The prime application for this technology is memory. Next type is the QFP or Quad Plot Package. The Quad Plot Package or Quad Plot Pack QFP is a package used for surface mount SMD integrated circuits. It is widely used because it enables SMD ICs with high numbers of interconnections to be used within electronic circuits. It is an industry standard package format, although a number of formats are available. These include variations on the number of pins and also variations on other aspects of the package as well. Next type is the PLCC or Plastic Leaded Chip Carrier. It is a form of SMD integrated circuit package that can be used to enable ICs to be mounted on a printed circuit board, either directly soldered to the board or within a socket. This provides options for the same IC to be used during development where the PLCC may need to be removed periodically for reasons like updating firmware. When the design is stable, the PLCC can then be soldered to the board. These options can be achieved because the PLCC has its connections leads on all sides of the chip which can be connected with the socket. The leads are then in a form of a J, which enables them to be soldered to the board.
Another type of packaging is the LCC or the leadless ceramic chip carrier. So it is an IC package which is usually ceramic that has no leads or pins. It instead uses metal pads at its outer edge to make contact with the printed circuit board. So this makes the device more easy to fit to the PCB. For fabrication, the IPDs can use substrates that are rigid like ceramic, layered ceramic, glass, silicon coated with dielectric layer like silicon dioxide. It can also have substrate that are flexible like laminate, FR4, Kapton, or any other suitable polymer. So it can be considered beneficial if the designs and effect of these substrates can be neglected in accordance to the performance of the integrated passive devices. The manufacture of these include thick and thin film technologies, which are ranging from nanometers to micrometers in measurement. IPD on a silicon substrate are generally fabricated using wafer fabrication technology such as thin film and photolithography processing. In photolithography processing, it uses light to transfer a pattern to a photosensitive material. So in this figure, you can see a P material and N material in a silicon substrate. So there will be an adhesive layer and reflector, a bonding metal, and there will be wafer bonding using a silicon receptor wafer. So the silicon substrate will be lifted off. There will be etching, roughening, and pad, and lapping and of the backside metal. So integrated passive devices and IC technologies may differ as passive devices may utilize different materials. So they can use thicker metal for higher Q value of inductors, different resistive layers for more resistance on resistors, or thinner or different K for dielectric layers for higher capacitance for the capacitors. So IPD silicons can be grinded below 100 micrometers in thickness through many packaging options such as microbumping, wire bonding, and copper bands. 3D passive integration in silicon can be used in manufacturing these passive devices. So through 3D passive integration, this enables high-density trench capacitors, high-Q inductors, PIN diodes, or Zener diodes. The design time of these passive devices in silicon depends on the complexity of the design in which the desired output is depending on. So as observed in this picture, the passive devices are implemented in the integrated circuit that so that it can perform its purpose. So for the importance of integrated passive devices, first is the reduction of number of parts to be assembled in an electronic system. To minimize the area and volume of electronic devices such as wearables, portables, medical equipment. So these are useful for devices such as smartphones to minimize their dimensions but still maintain their specifications. For medical equipment such as hearing aids, it is important for smaller parts in this device. For the reduction of weight of electronic devices, and this is also useful for designs in need of passive components of several same values, such as low value capacitors. And last, it is more reliable in use between other technologies if minimization is required, such as packaging of active ICs in need of passive components.